Hi, I just wanted to take a moment to congratulate you on making it this far in the course. In our last video, we roughed out the part completely. In this video, we're going to finish it. So hopefully we're going to learn some new things in this lesson, and it's going to be quite exciting because I'm really excited to get into all of the finishing toolpaths because that is my favourite part. Okay, and also I'd like to thank everybody who is subscribing to the channel. We're almost at 100 subscribers, so it's quite a big milestone for a new channel like this, and also someone who's very new to this in front of camera and new to the whole YouTube thing and making content. So it's very different for me, and yeah, I'm enjoying the journey so far anyway. So yeah, let's get into the video.
Okay, so in the last video, we managed to rough out this part completely, as you can see here. So now we're going to be moving on to the finishing. So one way that I like to structure my program view up here is I will now create a folder called finishing, believe it or not. So let's just insert a new program and call this finishing. Okay, that again. And now inside here, I'm going to have another subfolder. So I'll just copy and paste this folder now, and I'll just dump it inside there. So now we have a folder living inside a folder. And I just like to separate out my different kinds of finishing. So to begin with, we're going to do planar finishing. That's what I would call it. So planar finish. And then, so planar finishing for me would be this top face, which is a planar face. These outside faces, again, are planar. These cutouts. This chamfer. These pockets. And then this rad is not planar. So really thinking about it, the only thing that isn't planar is that rad, because we're going to have to scan that on. So we're going to have to surface that with a surfacing toolpath. But then again, thinking about it, you know, I am doing this course. I'm like, this isn't a script or anything. I'm just doing this on the fly. So actually thinking about it, I actually don't need multiple folders because it would only be one toolpath, which would be the surface in there. So I'm just going to get rid of that. And yeah, we're just going to put all of the finishing inside this folder then. So the first thing that I'm thinking about is this pocket here. So this pocket, if we just take a quick look at the drawing. So let's put that on the screen. So you can see the only real things that we're worried about is this thickness, which we're not going to be doing in this op. That'll be from our second side, so we don't have to worry about that. These holes, which are looks like they've got a position on them, so they are plus or minus 0.2, the distance, and the same here. And then our width and length is also 0.1. So I mean, this 0.1, any modern milling machine, you know, it's going to be pretty close. Yeah, I'd like to think you'd be able to hit this without worrying about tolerancing, but we are going to do it as if it's a tied up face. So my general thought process here is I like to finish everything that I can last. So all of my actual sizing and stuff is going to be done at the very end of the finishing program. So let's go back to the part. So now I need to think about what tool is going to do this pocket here. So this isn't going to be a production part. We're going to program this as if it's a one-off part. So I can see here that this 4x1 would actually be perfect for this, because we sized it up before. We made sure that these rads weren't too big or too small, sorry, for the tool. So I'm going to use this 4mm end mill again, and I'm using that first because I don't want to do another tool change. You can see here on this column type, if we just pull this out a little bit, so you got tool change. So what this is saying is there's going to be tool change on this toolpath. There won't be on this one because it's using the same tool. And then again, there's going to be a tool change on this path. So ideally, Depends if you're working in production or not. If you're not working in production, it's not like super critical. If you're only doing like 4s, 5s off, this isn't like super important. This only really gets important when you're doing 100 off and so on and so forth. But for this instance, I don't think it matters too much when we finish these pockets, because they are only weight reduction pockets. There's nothing that important about them. So let's go and finish these pockets now. So for me, these pockets to me look like a nice planar toolpath. So let's have a look at what we've got. Maybe we'll play around with a few different ones and I'll show you the differences. But for me, as I said in a previous video, this planar mill is really powerful. You can use it in lots of different ways. I could probably go and finish this whole part with just this toolpath. So let me show you how we can do these pockets. So again, I'm using this like quick access bar here. This is just going to quickly insert this into the toolpath. And our method is going to be finishing this time. Okay. So in our main, this is a thing that you won't have seen before yet. So specify part boundaries. So this is asking for how do we want to contain this toolpath. So you've got a couple of selection methods. You can select by face, which I very rarely use, but I'll try and demonstrate it here. That's not great. So yeah, I wouldn't use face in a situation like this. I would always use curve. So in the selection method, we've got curve. And again, we're not going to select them all singly. I want to select this top edge here. You can see it's like trying to close it off for me because we've got the boundary type as closed. So we can go around and select them all individually like this, or we can just get rid of that. And a better way to do it, which you need to get into the habit of doing it, is tangent curves, and there we go. We just get all of it nicely in one. So the boundary type. So this is asking, are we working in an enclosed profile or are we doing an open profile? So here we're doing a closed profile because it's fully closed. There's no gaps. If you wanted to just finish this face, for example, then this will be an open profile. You could select this one line and the tool's going to come in and finish this face and just come off again. So here we want to work in an enclosed area. The tool side. So do we want the tool outside of this boundary? So do we want it to be over here and working around the outside of it? Or do we want the tool inside? Obviously, we want the tool inside here because we want to finish this pocket. And plane. So the plane is the top level that your tool is going to start. So for example, if I select this face, you can see it's drawn the line on this top face here. If I select this face, well, you can't see it now because it's inside that rad, but I could pick it up slightly, and now you'll see the line is being drawn at that height. And this isn't super important. It's only important if you're doing multiple step downs. So in this case, we're going to be finishing it in one pass, but I'm going to set it to this top face just to show you how we can manipulate the step downs and stuff. Okay, so that's our top face, and that's all you need to worry about here. So you can see this generate button on this planar path is called automatic generate. So as we start changing things in this toolpath, you're going to start seeing the toolpath start coming down. So the reason why it's not generated anything just yet is you can see here there's an alert that's saying there's no floor plane that's been specified. So then let's go and set the floor plane. So the floor plane is the most bottom level that you want the toolpath to go to. So in this case, we want the toolpath to be touching this floor because we want to finish this floor and this wall. And you can see there's arrows here. So you see this arrow's pointing up and this is pointing up. This arrow is your tool direction. So this means we're going to be coming down the tool this way, which the tool is going to be pointing down this way, which is right. If it was the other way, then it's going to be trying to machine the pocket from this side. Okay, so now you can see it's given us a toolpath. So I like planar milling because I like to see the toolpath straight away, and it gives me a better feel for the changes that I'm making and how are they affecting it. So straight away, I can see here that this step over is way too small. So let's increase this to 80%. So now I can see we're starting to roll over these edges here, and it's starting to get a little bit messy. But we'll come back to that in a minute. So if we just reduce this down a little bit and a little bit more to stop them rolling over. Okay. And we'll sort this out in a minute. I don't like these sharp edges, but again, we'll get to that. Okay, so that is our percentage of diameter. We set the step over. So the floor stock, we don't want anything on there because we want to finish it completely. And we don't want any other stocks on there. We don't want side stocks. Our depth of cut. So it's currently set to 0, which means it's going to do 1 full pass. So we can see we have this option here. We can actually, let's change this to 5mm, and you'll see now it's taking into account where we set our top level. So it's doing 5mm from the top level and then 5mm down again. This second one might not be 5mm because it doesn't work it out like by halves. It's doing 5mm from here, and then whatever the remainder is, it does from there. So for example, if we put 8 in here, you can see we're doing 1 8mm pass, and then it just does whatever it needs to do to get to the bottom level. You can do user defined, which you can set, you know, different distances from the top, but for this we're not going to get too into this course because 90% of the time this is totally fine here. We don't want to go too in depth. Okay, so like I said here, we don't want anything, we just want to do 1 pass. So geometry, this is all good. Tool axis, again, this is all fine. Feeds and speeds, so 4mm, finish in a pocket like this, I'd be thinking something like 8,000 speed and 800 feed, something like that. Okay, so that's our speeds and feeds set. Cut regions, it's not really applicable in this case. Strategy, our cut direction is climb milling, as we always want to be doing. So add finish pass, we'll get onto that in a moment. Top off critical depths. So we don't need that. I don't think it actually matters in this case. No, it doesn't do anything, but yeah, let's just leave that off for now. Cut order, so level first, because it's only doing 1 pass, so it doesn't actually matter. Smoothing, so I don't like these sharp corners here. So we're going to add some smoothing to the toolpath to get rid of them. So you can see how it's smoothed all the passes out, but now we're getting some weird overlaps, and that's because we've gone too far on the smoothing radius. So let's just bring that down a little bit. Okay, 15%. So we can still getting these rollovers, and we want about a 20%. That should be fine. 20% smoothing should be fine, but we're going to have to reduce this percentage of flat diameter slightly. And that should help get rid of these overlaps. Okay. So now we've got these smooth connections coming all the way down to the floor of the pocket. We've got these nice smoothing connections coming out. And it all looks good. So the next thing I don't like is, oh sorry, let me just go back onto the smoothing. So with smoothing, you have all passes and you have all but last pass. So this really depends on what you're doing. Like if you're roughing, I would always recommend using all passes. If you're finishing, for example, so let's just play with this here. Let's just say all passes. And now we can see this is completely finishing this wall, so you can see it, you know, it's size for size. And this looks a little bit strange because we need to tighten up our visualization preferences. So let me show you how to do that. It looks like it's gouging here, but that's just because the models aren't completely refined. So if we just type in the top right corner, visual, now you see visualization preferences, and let's just chuck all of these right up to the top in accuracy. And now you'll see it looks a lot better. So now you can see it's a nice thin line. We're finishing that wall perfectly. So if we increase our smoothing tolerance, let's say we go 70%. We still finish it. So we'll have to go quite high on this. So now we've gone 200% smoothing radius. You'll see it started to stay off this wall now. And that's because the tool physically can't get into this corner anymore. But you'll see if we switch this to all but last, what happens is it smooths all of these inner moves, but the very last move against the wall, it will do as tight as it needs to go to finish it. So this is a really handy tip to know for this smoothing radius. So in this case, we're just going to leave it on this, but we're going to drop this smoothing back down to something which is a bit nicer, like that. So that's a really nice looking path on that floor. So connections, this is fine. So the next thing I don't like is this engage, because we know we don't need to helical from this step, because we already have roughed this pocket out to 0.5 mil above this floor here. So I'm going to change this. So this is, we're not in an open type, we're in a closed area here. So that's why you can see it's using the helical motion, it's not using the linear. And we're in an enclosed area because we're in this closed pocket. So let's drop, the diameter's fine at 90, that's fine. The ramp angle is fine. I mean, it's a little low, but the main thing that we need to check here is the height from. So it's taking the height from the previous level, which it thinks is the top face here. So it's 3 mil above this top face. So we want to go plane. And here we can set where we want the height to start from. So I want it to start from this plane. And now you could, I mean, I would normally leave this at 0 and I would use this height of 3 mil here. So I would want this to be 1 mil above because I know I've roughed this out to 0.5 mil. So now we should see. Yeah, now we've got a nice small engage, and that's just going to save time on the machine. So what I was going to say before is you could either set the plane and go like 1 mil above and leave this at 0, or you can just leave this at 0 and set the height here. I prefer to set the height here, but that's personal preference. Okay, so minimum clearance. This is another important one to know, especially if you're working in a really tight space. So as the sort of little picture on the toolpath describes here, this is how far away from the wall that you're going to stay. So you can imagine if we were only in a 5 mil width pocket and we're trying to finish it with a 4 mil. If you're engaging down, sometimes your engage could be hitting the wall as it's engaging down like this. So by setting a minimum clearance, you can say on the engage, always stay 0.5 mil away from the wall. So now onto the retract. Again, I don't like this. I don't like this sharp coming off. It's just not nice to see. It's a horrible sharp corner for the machine to deal with. So I'm going to change this to an arc. So now you can see it's arcing away. Again, it's too far for me personally. I don't like how far it's coming into the part. So the radius is fine, but I'm going to get rid of this extend. So this extend should bring it in slightly, and then the height is fine. It's not really that important. The radius, let's bring that down to 25%. And also, like, whether you move this far off the job or this far off the job, it's irrelevant because we've finished this wall. This wall has just been finished. So I like to just, this arc angle is taking it to 90 degrees from off the wall. So I'm just going to reduce this down to say 30. And now you'll see we get a much tighter retract away from the wall. So it's clear. Maybe just go a tiny bit more for good measure. Something like that. So that's totally fine. Other than that, now this toolpath is starting to look pretty good and I'm quite happy with it. The height is going to play a bit more of a factor in a moment, as we're going to do something pretty cool. Here is nothing that we need to worry about. We don't need to do any collision checking yet on this part. We know we've got enough flute, do we? Yeah, we have enough flute length. So that's all good. So one thing that I would like to add here is I would like to add a little finish, a semi-finished pass on this wall. So if we wanted to do a semi-finished pass on the wall, I like adding it here in this finish passes. We can do an add finish pass. It adds you how many finish passes you want to add. So we just want one. And then here I like to just set 0.1 of a mil. So now you can see it's actually doing, it does the normal path as you've seen before, and then it comes and does this very last finish pass just to take the edge away. And this just does a nice little fresh cut, and this will give you the best finish possible. So now I'm happy with this toolpath. And now you're probably thinking, oh well, now I need to go and do the same for these, but I would just include them in this toolpath here. So go back into your part geometry. So how we have this selected now, you can see how we have this add new set. So we're going to add a new set. We're going to change it to curve. I'm going to go to tangent curves, and now I'm going to select this line. So a quicker way to do this is if you hit the middle mouse button. So if you hit the scroll wheel, if you just click that in, it's going to automatically create you a new set, and it keeps on tangent. So now I can just select here, hit the middle mouse wheel, and select here. Okay, and that is all 4 pockets finished. So yeah, it's fine. It looks good. The next thing I would look at is these transfers. They're a bit high for me. So I'm going to come in there, and I'm going to look into my transfer and rapid, and I'm going to just set it to automatic. I go 5 mil above, so that looks okay. And then the next thing I don't like are the sharp corners here. This is personal preference, and probably most people won't do this, but I always like to try and avoid these sharp corners here. So I'm just going to add some smoothing to the top corners, and I'm going to say, because I know I'm 5 mil above the job, I'm going to go 5 mil, and we're going to get these really nice traverses now. And this is just going to be, you know, it's going to be nice for the machine, because all the fast, rapid, sharp moves, it just doesn't do machines any good. And this is just going to, and it looks better. It looks better. It looks like you've taken more time and more thought in the toolpath. Okay, so pockets are finished. Now we need a tool which is going to finish this top face, this outside profile, and these little pockets here. So when I'm thinking of a tool which would do these, the one thing that stands out to me is, what is this radius here? Because this will determine what diameter tool I use to finish this. So let's check that out in analysis and measure. I'm just going to click this and change it to diameter. So 11 mil. So I can use a 10 mil tool at most. 10 mil tool, that's okay. Probably a little bit on the excessive side. Maybe, you know, we don't want to go too close to this diameter. That only leaves 0.5 mil. And what happens is the tool's going to come in here, and it's going to be a really sharp, it's going to be a very small radius. It'll be 0.5 mil actually, but the smaller tool you go, the more the tool gets a chance to move around this radius smoothly and give you a much better surface finish. What you can find is, if you use a 10 mil tool, depending on your feed and stuff, as you start to finish this wall, the closer it gets to the very corner, it can grab the material and leave you a bit of a chattery finish. So I'm going to specify an 8 mil tool for this, and I just want an 8 mil sharp end mill. So let's create a new tool again. Insert, tool, mill planar. We want an end mill, and this is going to be 8 mil end mill. The diameter is 8. Lower radius is 0 because it's going to be a sharp end mill. The length is probably around 50 mil. Flutes are going to be 3. We're not going to, oh, flute length there is 50. That's not right. So on an 8 mil cutter, going to have around 18 mil, something like that. Flutes 3, and here we're not going to worry too much about the relief diameter. So this is tool 3. Okay. So now we have our tool built. So let's go and, I mean, it's a planar mill again for me to do these outside walls. You can use, so like, for example, in these pockets, let me show you just not too quickly, I guess. So in mill planar, you've got a few options. So you have floor facing without wall. You have floor and wall. So when you look at this, it is a floor and wall operation type because we have a floor and we have a wall. So let's see the difference with toolpath here. See if we achieve the same thing. So specify the cut area floor. So the floor for us is here, 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 and here. Specify wall geometry. So a cool thing with this is you have this automatic walls feature. So we can tick this on and then hit the eye and you can see it has picked the walls properly for us. And the way that works is it looks at the tangential surfaces off this floor. So it's picked them automatically for us. Extend floor, so just do none. That's we can get into that at a later date if we need to. Follow periphery, so it's going to follow the periphery of this profile, the pocket. Blank, as we've mentioned before, I like to use thickness because it's much quicker. We're going to say there's 0.5 mil on the floor and 0.5 mil on the walls because we know that is the case. 75%, that's fine. Depth of cut, that's fine. It'll just do one pass. That's all the same, that's the same. I'm not going to be worried about that for now. So this is going to be important in future videos. Exact positioning takes into account the tool radius of the tool. So if you're using, whereas this rad is a 1 mil, if you were using a 0.25 mil, it would finish 0.25 mil over this line. So it finishes all the way up to the floor as much as it possibly can do. Strategy, we'll look into that in a minute. Let's just try and generate something, see what we get. Okay, very similar toolpath. This potentially might be quicker. We can add finish passes as well. Let's see if we can achieve the same thing here. Add some smoothing on there so you can see it's done the exact same thing where it started to overlap itself. So let's change that to 20 and change this down to 50 because we learned that before with the step over, didn't we? Where is my step over gone? Here it is. Okay, so yeah, I mean, it's very, very similar. Possibly, maybe faster? Possibly faster to do from scratch. I don't know. We still have to do all the engages and stuff and look into the finer details, but that was pretty quick to get a half decent toolpath. So yeah, a couple of ways of achieving the same thing. And again, there'd be maybe 2 other toolpaths that could do the same thing there for you. One thing I would say with NX is there are multiple ways to achieve the same thing. So here, we've just done an example there, 2 different toolpaths, and they have done the same thing essentially. But also another thing I would add to that is, although there might be 4 toolpaths that can achieve the same thing, all 4 of those toolpaths will be very good in their own rights at very specific things. So what will make you a really good NX programmer is knowing all of the toolpaths very well, because they all react very slightly differently, and this will give you a much better advantage over anybody else because, yeah, like I say, they all do come into their own at certain times. So we got this nice toolpath here, and that's finished our pockets. Now I'm just going to copy and paste this for efficiency. And now I want to do this outside profile. So in the main, I'm going to switch the tool type to the 8mm mil. In the part boundaries, we're going to now get rid of all of these selected features there. And in the curve section, it's closed again, and I'm going to select this bottom curve here. This bottom curve is easier to select than working around this edge here and then coming up and around again. It's just, yeah, you can select it nice in one thing. And now I'll select the plane as this top face. So you can see we've achieved the same thing. We've just got this nice outside profile. Okay. So our floor now our floor needs to be just below this face. So then when we flip this part over and we take away the top, we finish the part complete. So the way I like to do this is I would select this bottom face, and now you can see the direction is the wrong way. It's coming in this way. So you can either just double click this face. So double click the arrow, sorry. And double click that again. And then I'm going to say I want to go -1 mil from that bottom face. So let's just check this again because our tool side is on the inside. I've noticed it's given me a toolpath on the inside of the part. So that's because our tool side is inside. So we want to switch that to outside like that. And we want to change the cut pattern from follow part to profile. And that's just going to give us one pass. Okay, that's nice. All of this doesn't really matter now because on profile you're only going to get one pass anyway. If you were to do additional passes, so let's say we do 10 additional passes, you can see it's expanded them out, but obviously we don't want to do that. Okay, so geometry is the same, tool axis is the same, feeds and speeds roughly the same, probably a bit different. For an 8mm mill, I'd be like, yeah, probably 8,000 speed again. I would have maybe gone slightly faster on the 4mm. And yeah, 800 sounds fine. Okay, strategy. So there's no point in changing this because it's not affecting the toolpath, but this is now irrelevant. Our engage, so you can see our engage is really sharp here. So we don't want a linear engage. We want to change that to arc. And let's just say 1 mil. And you can see it is doing a 1 mil engage, but then we're also getting this extension, and that comes from this here, this trim and extend. So let's get rid of that. The next thing is I'd probably start slightly further away, just because we do have 0.5 mil of stock on there. And then I would reduce this down slightly, just so it's not too sharp, something like that. And then this height, we're working on the outside of the part now, and we're not coming down into any stock, so it's pointless having this height here. So we're going to take that straight to 0. Okay. And now what I'm going to do is in my retract, I'm going to put this back to same as engage, so then you get the same. Okay, so this is going to be one nice pass around the outside, which is going to finish this outside profile. And that to me is fine. The next step, well, this is actually essentially a tied up face, isn't it? We do have a 0.1 tolerance on here. And depending on what machine and tooling you're using, you might have to actually size this in. So let me do it as if we are going to do that. So first of all, if we are going to size this in, not only do I need to do this outside profile, I also need to do these pockets and this top face. So what I'm going to do here is I'm just going to leave a little bit of stock on this face. So in my mill rough, I don't actually have an ideal stock level. I think semi-finish will take us to 0.3, which is a bit odd. I mean, that might be normal to some people, but I personally like to go to 0.1. So I'm going to change my mill semi-finish group, and I'm going to just change it to mill semi-finish 0.1 mil. I want to leave 0.1 whenever I use this group. So I'll come in and I'll change this to 0.1. Don't know why I put millimeters. Intel out to 03, that's totally fine. Okay, so now you can see that the toolpath actually lives inside here as well. So you can see the toolpath from here. So now if we go in here, we should say it's updated because it's inherited. So we generate that. And now if we drop the tool in, we should be able to see. And by the way, when I'm snapping to like a face here, I'm pressing F8. F8 snaps you to the nearest axis type. So looking down on this X in this case and Z in this case. Okay. Yeah, so we're leaving 0.1 of a mil on there. So now I'm going to come in and I'm going to finish these faces, these little pockets, and I need to finish this top face too. So if we want to finish this top face, essentially we did have a nice toolpath here, which we could just use to do that. So let's copy this toolpath and we'll paste it down here. And I'm just going to change the tool. Our floor stock is now going to be 0. Floor bank thickness is now 0.5. We still want a zigzag. These overhangs might change slightly, so we'll just generate it and see what we get. Yeah, that should be it. So that looks like a pretty good toolpath to me. So that is just one way you can, utilize a similar toolpath that you've done before. The only thing we need to think about changing is our speeds and feeds. This is going to be different now for here. So we'll do 800 and finishing a top face like this with the bottom of the cutter. You can go a little bit faster. So I'll be thinking maybe like 1800 feeds, something like that. Okay, so that's the top face finished. So now we've finished the pockets. We've finished the outside profile. We've finished the top face. So we just need to do these cutouts now. So again, there's probably multiple different ways we could do this. Let's try it a different way. Personally, I would just use plain on mill again because, like I say, I like this toolpath. It's very versatile. But for the use case of this video, let's try something different. So we'll go to the mill planar type and let's just start looking through. And it's good for you to sort of try and go your own way with things and learn a little bit like that. So when you hover over, obviously you get a really good description. So I'm thinking, obviously that's not going to work. It's not going to be face mill mid pass, face mill zigzag. To me, it doesn't look like it makes sense on this sort of a pocket. Floor facing without wall, not really, again, because we do have a wall. Floor and wall, well, this is a floor and a wall. Pocket milling, 2D profile wall without floor, so not that. 2D profile wall with floor. So I mean, yeah, this could be the toolpath. I don't think I've actually ever used this one, but let's give it a go for the case of this. Okay, so you can see all the geometry is very similar. So let's specify our wall geometry. And again, let's utilize tangent. Okay, so we have our walls. Let's see if, oh yeah, we can select the floor here as well. So that's one floor, that's one floor. Like so. So part stock 0, 3D IPW, let's say thickness, and we'll go 0.5. Step over 75%, that's fine. Depth per cut, that's fine, that's fine. Tool axis Z, yep. Feeds and speeds, we're going to say 8,000. 8,000 and Jesus, what's wrong with me? 8,000 and we'll say 600. And I'm saying 600 is because this is such a small area. The faster you go, the more this corner here is going to chatter. We did go with an 8mm, which is slightly smaller, which will allow it to roll around here a lot more. But it's such a small area that 600 is probably a good feed. You want to go a bit slower and stuff like this. Okay, so extending this. We're not going to look at this yet until we actually generate a path and see if we need to. Smoothing, it's not too relevant in this case. It might be for our extra pass that we might need to do. Yeah, let's just see what we get here. Okay, not bad. So it's given us a toolpath and it's pretty good. We need to actually change the tool there. I've just dropped in and noticed I've got the 4mm, so let's switch that out and regenerate again. So now we are coming in and we're finishing this wall. So you can see that we need to add an extra pass because obviously we're not finishing this area here. So let's go into our percentage of flat diameter. So that's our step over that we're going to be doing, and we want to add another pass. So now we have another pass. So now smoothing is going to play a factor, because I don't want this here. I don't like this corner. So let's add some smoothing. We're going to do all but last, because what I do to this corner, I don't want it to apply to this last corner. So now I can see if I drop in the tool like here on this location, and just sort of take a picture in your head of where this is here, and now I drop in over there, and I can see I've not finished this properly. There's a bit of land here, so I can see the tool is sort of just above this pocket, whereas here the tool isn't. So it's going to be very close to not finishing this, so I need to reduce either my step over or the smoothing, and for this I'm going to reduce the step over because I like this bigger arc. So let's reduce this to 40%. So this is much better. So this is spot on now. So now what is the next thing we can improve? So I don't like the engages and retracts. I don't like the step overs, the traverses to the next pocket. So let's see what we can do about that. So what do I want to see? Now I'm visualizing in my head. I always like to visualize the toolpath I want before I start letting the toolpath dictate to me what I can do. So ideally I want the tool to start somewhere over here and roll around and come out again and roll around to that location there. I don't want it I don't want this around here, up, over, down, around. I want it to be down all the time, and I want it nice and smooth. So how can we do that? So if we go into strategy and in our cut levels, so currently it's going to level by level, but we want it to stay at this depth as long as it can. So let's change this cut depth. Oh, sorry, that's not. I was thinking of by level and by depth. So that's not in this area here. So let's see if we can get the engage tidied up. So engage. What options do we have here? So I still want it to arc, but I want it to come to the middle here. And then the first thing actually is let's get this move direct so it's not coming all the way up. So let's get rid of the height on this. So generate that. So now we can see we've got no height, so it's dropping straight down, which is nice. And let's just verify this just to see what we've got. Sometimes it's better just to visualize it. So we're dropping down to position. We're rolling around this first line. It's coming all the way up, all the way over, back down, and then it's going to do this second line. Yeah, so that's not, I don't like that. So the way that you control that movement in between, so the movement here is we go into our traverse, transfer and rapid. So let me explain this a little bit to you. So you have clearance, which is the main clearance plane. So that's this red line here, the top plane. You have between regions. So a between region move would be anywhere from this region of cutting to this region of cutting. And then a within region move is anywhere working within this region. So for us, what do you think this is going to be? If we want to restrict the movement between here and here, is that a within region move or is it a between region move? Okay, so hopefully you said it's a within region move. So this is how we need to control this. So we want to transfer using engage and retract still, but the transfer type is going to be direct. So you can see, again, you get really nice pictures showing you what all these different ones do. For us, we want to move directly. So now I can see I've got this green line. So it's going to come around here. And this green line is going to take us nicely to there. So next, let's look at the engage again. So, I mean, this toolpath is totally fine. Let me just say that now. But I'm trying to set you apart from the majority. We are looking into these smallest details here. This isn't going to make any difference to the part whatsoever, but as for you as a programmer, it's going to set you apart like night and day. 95% of programmers won't be looking into it this deeply. So this, you see this extension here, that's coming from this 3mm extend. So let's just get rid of that. Okay, so now you'll see it's a bit different. And I'm thinking it might be really nice to add potentially like, let me just think about this. We need to get these corners as close together as possible. So maybe we can do that by having a slightly bigger radius and increasing this angle so the radius comes back on itself very slightly. So that would be about 145 degrees potentially. Let's see what we get there. So now this move is a bit better. So you can see we're getting a much more of a roll. So if we just decrease that slightly now to 1. I'm saying decrease because here it looks quite smooth, like really nice and smooth. But then here you've got this little juddery corner there. So let's just see if we can get rid of that. So it's a bit smoother there. It's sort of the in-between between both. Okay, so now it's going to roll around nicely. And it's off the part, which is good. The next thing is these engages between the between regions. So transfer rapid, I want that to be automatic 5mm from the top face. You can see there it's a bit lower. And then we're going to add some smooth corners again. So now that is a really nice toolpath. So you can see again we've used a different kind of toolpath, one that I've never actually used before, but we've achieved the exact same thing as we could have done with a mill planer. And the more you get to know these dialog boxes, the more you can just experiment yourself and you know what all of these different things do. And when you get to that stage, then you can start trying different toolpaths and just experimenting on your own. Well, I'm happy with this. This is a pretty nice toolpath. Let's have a look. We'll do right click, toolpath, verify. So this is just the same as using this one up here. And let's see how this looks. You got a nice roll around over the top, down again, a nice roll around, and over to this side. Yeah, nice smooth movements. Okay, so now what have we got? We've got the pockets are finished, the outside's semi-finished, the top face is finished. These little pockets are finished. These little corner pockets are finished. So now we just need to go back and we need to finish this outside profile. So I'm going to copy and paste this toolpath. I'm going to change the geometry, the tolerance and clearance. I'm going to change it from semi-finished to finish. I'm going to then come into my tool axis and cut a comp. So cut a comp is obviously a massive thing for most companies, and you're going to use this on almost every program you do probably. So cut a compensation, we want to add it to all passes here. I mean, I've never really seen too many use cases for the final finish pass, but as it describes, if we had multiple passes here, so multiple passes doing this wall, it would only apply the compensation to the last one. But most of the time, all finish passes is probably pretty fine. So the minimum move is it needs a minimum move to be able to apply the cutter comp. So for example, if you say the minimum move is 10 mil, for example, it would never be able to apply the cutter comp because this movement is only actually roughly about 1 millimeter. Actually, no, it's probably a bit more. If this is 4 millimeters, so that's about 2.5 or something. So that's something to bear in mind. Normally, like, you could put this as low as you realistically want. So, I mean, in the past, I've always just put this to 0.1 and I've never had really many issues. The minimum angle, again, is the same thing. I've always actually just left that at 10 and I've never worried about it. So now here comes the big change. So this toolpath is now done with cutter comp, but whether you use tool radius or you work from centerline, that is the difference here. So this box here, if your company works with tool radius, then you're going to want this ticked on because this is going to finish it directly up to the wall and it's going to use the radius of the cutter. So in where I've worked in the past, I've never used tool radius. We always work from the center line of the cutter. So like this. Okay. I think that is this toolpath complete. So now we've finished the outside wall. So you're probably asking, like, why have I finished this in a separate toolpath? And that's because I want to apply a stop. This is where I want the program to stop and I want the machinist to be able to check it on the machine. So how do we add a stop? So I'm going to introduce you to something new now, and this is a whole topic on its own. So we're just going to briefly go into it. So to add a stop, the best way that I believe and the quickest that I would use would be going into object. And here you have start and end events. So these are events that either happen at the start of the toolpath or at the end of the toolpath. So in this case, we want to check the toolpath and we want to check the size after the toolpath is run. So we're going to add an end event. So in here, you have a lot of options that we're not going to go over now, but the one we're looking for is stop. So we want to add a stop to this toolpath. And here you can display the text that you want the machinist to see. So we could just put here, size outside profile. And normally, if it was me doing this in production, I would put a little bit more information. I would say size 120 plus or minus 0.1 and size 50 plus or minus 0.1. But that's going to be dependent on you. So now this whole sort of, I think this whole part is finished now, other than the holes and some other bits and bobs. Oh, actually, we need to do these rads. So again, we know we need to use a 4mm tool, ideally, to finish these rads, because the ball nose is going to roll into here. So surfacing, this is my favorite thing to do in NX. I love surfacing. And for this tool, for this radius, we're going to need a ball nose. So let's go and add a ball nose. So again, we're going to come in here, we're going to create a tool. We want a ball mill this time, and let's say 4mm ball nose. So you can see how I add the underspace here, and that's because NX, when you're working in the operation navigator, you can't have any spaces. So what is this ball nose? Well, the diameter is going to be 4mm. We don't have any taper angle. The length is going to be, let's say, 50. The flute length is going to be probably around 12mm. Flutes, 3mm, 3 flutes. Relief, we don't going to have any relief diameter. And it's going to be number 4 for our tool number. Okay, so we have a ball nose. Let's add a new operation. So now we're going to look into contour again. So you can see this is where we found our roughing toolpaths initially. So what are our options for this? So again, NX, you have multiple options to do the same thing. My favorite is fixed axis guided curves, but for something like this, I'm not going to use fixed axis guided curves. I'm going to use contour area. And the reason for that is when you're using fixed axis guided curves, you have to select the faces and you have to select the first guide that you want it to come from and the second guide. So in this case, you'd have to do 4 toolpaths to achieve this. So we're going to just use contour area so we can actually select all of these in one. And within contour area, we're going to use the 4mm ball nose. We're going to finish it. Okay. So you're going to see some slightly new dialogues, and I'm just going to have a quick drink of water because this is becoming a long video. Okay. So in the containment, we have steep and non-steep. We have non-steep and we have steep. So let me show you the differences by actually generating you some toolpaths. So let's start with non-steep. So what is a non-steep? What does non-steep mean? Well, for example, this chamfer here, this could be classed as a steep sort of wall. And especially if this was, let's say, 80 degrees rather than 45, this could be classed as a steep area. Non-steep would be things like this top face. This top face isn't steep. This floor here isn't steep. So using the two, you can have different toolpath types. So let's do non-steep to begin with. So your steep angle, we can set this here. So we can say non-steep is anything over 45 degrees. So anything over 45 degrees would be classed as a steep angle. But in this case, if we want non-steep, then we want everything to be non-steep. So by setting the angle to 90 degrees, that's saying, well, everything below 90 is non-steep. So now we're in a non-steep area, we have these options available to us. We have follow periphery, we have spiral, profile, zigzag. So let's start with a simple zigzag. So let's do 3% of the tool for a nice finish. Whenever it comes to ball noses, I always use tool diameter. So 3% I know will give me a nice finish. Cut angle, we can leave that at automatic for now. Geometry, so now we just need to go and select our faces. So here tangent face wouldn't work that well because it's going to select everything. So what would be a better way to do this? Trying to think rather than selecting the whole thing. Probably just going to have to select these. Like so. So we have all the rads selected. Okay. Again, don't have to worry about stocks. Tool axis is always going to be ZM. Speeds and speeds, so I'd be at like 16,000 and 2,500, something like that, for a ball nose of that size on aluminium. Strategy. We don't need to worry about any of these in this case. So let's try and generate something and see what we get. Okay, so we have a sort of toolpath. It's not ideal. So you can see it's trying to zigzag, but the whole time it's maintaining the same direction of zigzag. So you can see here it actually looks okay. So this part here, it looks pretty good. But then you'll see like where it's not in X, it starts to look a bit strange. And that's because of the zigzag method. So, I mean, a popular one that people would use for something like this would be follow periphery. So we can generate this and this will look, you know, okay. So that's okay, but what you can see is, yeah, this is a bit you do see this a lot. I see programmers use this a lot, but it's not good, I don't think. You can see it does this horrible line. These are smoothing moves, so it's starting on the outside and it's working its way in. So it's rolling around the top, and then when it gets to there, it drops down and works its way around the other way. Spiral, we could try that. That could be pretty good. We'll spiral inwards and see what we get with there. So you can see once you've done the base of the toolpath, then changing these sort of patterns is very easy to do. So again, I'm not the big fan of that. And now I'll show you how we can use steep. So I prefer steep. In this case, I would use steep every day of the week. And we need to set our steep angle to 0 now. So we're saying anything over 0 degrees is steep. So that's just basically saying everything's steep. So now we've got this Z level helical. And this is exactly what I'm looking for here. Let's say our depth of cut is 5%. Now let's generate that and see what we get. Okay, so this is exactly what I was looking for. So one nice toolpath. It's coming down, it's helicaling all the way down to the bottom and then coming off. That's exactly what I want. So in this case, steep for me is always the best. So then steep and non-steep, let's just quickly touch on that. So we can say, if we do 45 degrees, what we should see here is anything at the top half of this chamfer, which is less than 45 degrees, it should use a non-steep pattern. So we can demonstrate that with zigzag. And then what you'll see is the lower half of the chamfer should use the steep cutting. Like so. So you can see how it's doing two different methods here. This is pretty helpful in certain cases, but not for this one. So we're going to change this back to steep. So again, I'm pretty happy with this. I'm going to change a few little things. So I'm going to come into my engage and I'm going to reduce this down slightly. The arc angle, I'm going to leave it 90. It's fine, to be honest. And then I want to change my traverses again. Okay, so there we go. I'm happy with that. That's nice. Let's just quickly have a look at that so we can see what the tool's going to do. So you can see it's going to roll all the way down to the bottom. And then over to the next. Nice. Okay, so now I believe we are pretty much there. We need now, and we should probably start looking at these holes. So I would say that is my main finishing done. So let's just double check and verify our toolpath and see what we get. Okay, so I can see we are complete. We need to do this chamfer, but I like to do that at the end because I also need to chamfer these holes. Okay, so it's time to jump onto the holes. So let's add a new group in here. So insert program, and I'm going to call this holes and chamfers. And I'm saying holes and chamfers because I need to do this top chamfer here, but it wouldn't really be classed as the hole. So it just makes a bit more sense to me. So this is pretty interesting now. So let's just quickly double check the drawing, which I closed down for some reason. So you can see the size of this hole is 4.2 mil. We have a plus or minus 0.1 tolerance. So ideally we're just going to use, ideally you use a 4.2 drill. But then when you look a bit closer, we have this O2 tolerance on the positions. So ideally, I wouldn't want to drill this hole. So I would like to either ream it. Actually no, I would definitely either ream it or helical mill it. And for the instance of this video, I think we should drill and ream it. So let's go ahead and do that. So a new thing that we need to sort of dive into a little bit here is how do we define holes? So there's a couple of ways of doing this. You don't have to define any holes. You could just create a toolpath, you could select this hole and it would pick it up. But if we want to work in a neat way, we need to look at something called feature-based machining. So inside of our workpiece, we're going to insert, we're going to add some geometry. I'm going to go to the hole making tab because that's what we're doing. And now you'll see we have this option called hole boss geometry. Let's use that. And I'm going to give it the name 4.2 holes. So now it's asking me which holes am I looking at. So I'm looking at this one, this one, this one, and this one. So these are my 4 holes, and you can see it's already defined them as through holes. It knows that they are through holes. So we have our group there now. So let's switch back to this view. We need a drill. So if I was going to drill and ream a 4.2 hole, I would drill it 4 mil and I would ream it 4.2. So let's add both of those tools at the same time. So I'm going to insert, tool, hole making. I want a standard drill. And this is going to be called a 4 mil drill. The diameter is 4.2. The point angle is 140 always for through coolant drills. So I'm going off the basis that we're using through coolant drills here. Because if you aren't using through coolant drills, then I mean, come on, they are really good. The length, let's say 50 again. Flute length, let's say we are 5D, so let's say 20 mil. Okay, and this will be tool 5. So we have our drill made up. Now let's go and add our reamer while we're here. So hole making, and now we want a reamer. And this is going to be 4.20 reamer. Okay. So the diameter of this is going to be 4.2. The neck is going to be, let's say, 4. The tip length, yeah, we can leave that at 1. Taper angle, that's fine. Distance fine. Length, let's say 60 mil. And then the flute length, yeah, I mean, 25 doesn't really matter for this. That is a long length. That is what she said. Okay. That is going to be tool number 6. So now we have both of these tools. We may as well add the chamfer tool as well while we're here. Why not? We're in the mood of creating some tools. Let's go and do the chamfer tool. So insert tool, mill planar, I guess. Or 10 parameter chamfer mill, and we'll just say 6 mil, 45 degree chamfer. So now I can say 6 mil, lower. Why does it keep doing that? 6 mil chamfer length. Would be 6. 45 degrees length. Wait. Okay, so 6 mil diameter, lower radius is obviously 0. Chamfer length is 3 mil because it's half of the diameter. Chamfer angle is 45. Length, we just say 50. and flutes too, that's fine. Okay, so we have all of our tools. Let's get this finished. So into our holes and chamfers. So now we need to add a hole milling type. So we go into operation, we go into hole making. Sorry, I said hole milling before, I actually just mean hole drilling. So now we want to use drilling. So you can see here you have quite a few different drilling options. We have spot drilling, we have drilling, deep hole drilling, and sequential drilling. Deep hole drilling and sequential drilling are very good, but they require very specific components and very deep holes. And for this component, just simple drilling is going to get you through 90% of things. So we want simple drilling. We want our drilling tool, which is the 4mm drill. So here, now this is where we select our group that we made before with the 4.2 holes. So we select our 4.2 hole group, and the drill method is always the same, so we can press OK to that. So now you're going to see some slightly different dialogue. So where it says specify feature geometry, let's just hit the eye. It knows they're there because we defined them before in here. We defined them here. So that's where it's picking this up from. So now we can look into this and see what exactly is it seeing. So it's seeing a 4.2 diameter, which is correct. It's seeing a 9mm depth, which again is correct. And it sees a start diameter of 0 because we haven't done any pre-work in here. And it's saying it's a through hole, and it's saying it's got a 140 tip. That's because it's taking it from the drill. Okay, so you see here there's a few options. So it's seeing this top chamfer, it's seeing the hole, and it's seeing the bottom chamfer. We just want face cylinder 1. If this was a multi-stepped hole, so let's say it was a counter bore, your cylinder 1 would be your counter bore, cylinder 2 would be the drilled hole. Let's do a drilling type. Okay, so here you have machine cycle or single moves. Machine cycle will try and replicate, dependent on your post. If you're using a Heidenheim post, for example, it's going to try and replicate cycle 203. Or if you use Fanuc, it's going to replicate whatever their drilling cycle is, and the same for Siemens. And then here you have a few different types. So you can do drill bore dragged, and all of these have very different options inside them. So if we see in here, we just have the option to dwell. If you change to drill deep or drill deep chip break, for example, or drill tap chip break, let's go to chip break here. Now we have chip breaking options. For this, we're replicating a through coolant drill, so we just want to drill through. Geometry, that's okay, we've set that before. Tool, that's all set. Feeds and speeds. So this is where whenever I use drills, I always use surface speed and feed per tooth. So for a 4mm drill, I would be at something around in alley 100. So I'd type in 100 and then hit this button and then hit the custom feeds and speeds. So you hit this and it'll populate this area for you, and the same for this. So I would be at about 0.1 per tooth. And now I can hit this calculator and it's input the actual feed rate for me. So into strategy now. So you can see we have, these are really important. So your top offset is how high above the hole it's going to start drilling, and your bottom offset is how deep through the hole you want to go. So let's specify 1mm and 1mm. That should be enough for us to generate this toolpath. So you can see the actual drilling path is starting 1mm above the job here, and it's ending 1mm through the job. That is 1mm with your tool tip accounted for. And that's because we have this option set here. It's to tip, not to shoulder. If we change it to shoulder, we might get a slightly different output. We get exactly the same, and that's because it's a through hole, I think. But just know that when you're doing blind holes, then this option will change that. Okay. So let's go on to the traverse. So we want to change it to automatic again, like we have been throughout. And we're going to change the transfer type. Sorry, not the transfer type. We want to smooth the corners again. Like so. So now we've drilled through here. That looks good. So now this is where I would chamfer the holes. You always want to chamfer a hole before you do any finishing in there, because otherwise you could potentially re-throw a burr over as you chamfer it. So let's go and chamfer our whole part now. So again, there are multiple options to chamfer. You do actually have a chamfer milling option, which is this one here. But that is, the planar deburring is actually for sharp edges. There is another one somewhere, maybe it's in contour. I think they might have got rid of it. I think it was a legacy toolpath. There we go. Yeah, it's a legacy toolpath, so we don't want to use that one anymore. So for this, I would use mill planar again. It's very versatile, as I've said. Or let's, for the sake of this, for the holes, I'll show you how you can do it using the feature itself. So in the hole making, you see you'll have this hole chamfer milling. So if we do hole chamfer milling, we can use that, and we'll say we want to use that tool. We want to use the geometry of the holes that we selected before. And now we'll see it's already selected the top chamfer for us, but we can select the bottom chamfer, but obviously in this case we're not going to do that because it's the wrong way. So that's fine. And let's just generate that and see what we get. So it has in fact deburred that quite nicely. But the issue with this is now I'm going to have to go and do this separately, which, thinking about it, I would actually have to do anyway because these are on different heights. So this is fine actually. It shows you both ways now. So you can see it's doing 1 mil below the part. So we're 1 mil deep into the hole. So you can change that. If we go 0.5 mil, you'll see that circle is going to get slightly bigger, like that. So this is, again, personal preference. I personally like the tool to move a little bit more. And the only thing we really need to change in here would be speeds and feeds. So let's drop this down to 3.5 and roughly about 200 because we're only in a small hole, so it's actually going to be quite quick. And I'm going to change the transfer and transfer heights again to same as. Okay. So now we want to do this outside profile. So for that, I'm going to add a planar milling. So here. And we want that hole. We want it in holes and chamfers. We want that chamfer tool. We want it to be under the workpiece. And we want to do finish. So now we select, when you're doing chamfers, it's always best to select the top of the chamfer. So let's just go and select all those. We'll try the tangent. Okay. Our boundary type is closed. It is a closed area. We want to be on the outside of the line. So we're not going to be inside. We want to be outside. And our plane, we're going to just leave as automatic for this. It doesn't matter. We could specify if we like, just to be safe. And this is the important bit. So our specify floor. So this is where do you want the tip to be? So I want the tip just to be a mil, just about a mil below. I think it's a 0.5 mil chamfer. So if we do -1, yeah, that's about fine. So this is where I want the tip of the tool to be. And now if I switch it to profile, I should get a half decent toolpath. And the great thing about mill planar is it knows how much it needs to step over by until it hits the face. That's why I like using it for chamfering. So you can see it's actually, you know, it's not working it out from this end here. It knows that it's about to hit this face, and that's where it generates the toolpath to. So that's really helpful. And again, we just want a better engage and retract on there. And our speeds and feeds need to replicate the same as the other one, so 3,500, but not 200 because we're in a much bigger area. Strategy, we don't need to worry about that, and we just want to arc on and arc off. Like that, and we don't want any height. Let's get rid of that. So that's nice. So I'm happy with that. So we've chamfered this and we've chamfered this top face. The last thing we need to do is actually just to ream this hole. So let's go and do that. So insert, toolpath, operation site. We want hole making. And now you'll see this one here, which is boring and reaming. So let's use that. We want to choose our reamer. And we want to go back to our 4.2 hole group so it picks it up for us. For this whole course, using machine cycle single move, it doesn't matter. This only really matters when you come to actually post, but single move is fine. So now we want to just make sure it's got them selected, which it has. Drilling, it's basically a drilling toolpath really. The only difference is we're going to change the retract feed so it doesn't wrap it out. Geometry is the same, that's all the same. So feeds and speeds, so for a reamer it'd be maybe for 4.2 it'd be 3,500, something like this, and 150, something nice and slow just to get that nice finish. And then again, our top offset and our bottom offset. So for this, it'd actually be a bit more. We want to make sure we are going a bit deeper. And actually thinking about it, I have made a mistake here. So let me just generate this. So I have made a mistake in this drilling because we need to also go through the block because we do have stock here, don't we? So you can see here I have the bottom of the block. So I want to make sure that the drilling is going, well, I mean in this case it'd be best if the drill goes all the way through, because then when the reaming goes, all the swarf's going to drop through the hole and you're going to get a better finish, because sometimes you can get swarf build up at the bottom of the reamed hole and that can force to break your reamer. So let's just go all the way through here. So we want to go strategy, and we'll change this to like 10 mil through. Okay, that looks a little excessive. So we'll go 8 mil through. And that's not too much. So we want to go 9 mil through. Okay, so now we're breaking all the way through. So now our reamed hole hasn't got any problems. And as the swarf's cutting, it's dropping down the bottom. Nice. So that is this done. Let's do our transfer in rapid as we have been throughout. And we're going to smooth that corner. And then the next thing I wanted to show you is the feed rates. So you can see in the retract feed rate here, it's currently set to rapid, but we don't want to rapid out with a reamer. We want to go, I like using percent of cut, and I would do roughly maybe 300% of cut. So if it's going in at, I think we said 150, it's going to come in, it's going to come out at 450. If you come out rapid, what you'll see is you'll see some scoring marks up the bore. They won't necessarily be scores, but you'll definitely see some marks of like the reamer. It'll be a very slight helical because of how rapid it moves out. So by using this, it makes sure that you get a really nice hole throughout. Okay, and that is these holes complete. The last thing I would like to show you is this edge is currently sharp. So I want to just take this edge away. On a 5-axis machine, I would come in, I would deburr all of this, make sure it's nicely done. But on a 3-axis, obviously, we can't tip over to do that. So let me just show you how to deburr that face there. So operation, we can use mill contour, and here we have this 3-axis deburring operation. So if we look into this, it's really simple, it's really good, I like it a lot. We go to workpiece, mill finish, we're going to use a 4 mil bore nose. Okay, like this. And you can see here we have the option of either letting it automatically detect all the sharp edges for us, or we can turn this off and we can specify the edges. So I'm just going to specify them, and I'm going to say this edge, and I'm middle clicking here to create new sets. This edge and this edge, middle clicking with the mouse, that is. So I've selected those. The depth that I want to go is, let's say 0.1. I want to just take 0.1 off those edges. That's all the same. Axis is the same. So here, this will actually take effect. We want to... actually, we haven't got a shank, so it is just going to be 0 up until the neck. So let's just put 0.25 in there. And it potentially will... we want to stay away from this wall a little bit. Fees and speeds, we're not too bothered about this for now, but... whatever. And let's generate and see what we get. Okay, so you can see it's done something pretty cool here. So these are all smoothing motions that it's automatically put on for us, because we have blend spine turned on. If you turn this off, it will change it back to just a normal approach and retracts like you would expect to see. The blend spine is actually really cool, to be fair, and I use that a lot, especially on like a bit more complicated parts, but for this, it doesn't really matter too much. It does make things nice and smooth though, which I do like. So let's just put on here and let's see. So you can see we are staying away from this wall, we're not gouging it, and you can see we start to cut that 0.1 here. By dropping on, you can see we're just taking that edge off there. So this is a really nice way of just deburring all the edges that you don't want the machinist to have to manually deburr. When you have a toolpath like this, there's really no excuse not to be doing deburring on the machine. Okay, so let's just have a look and see what our part looks like now. I think we should be finished there. So let's double check. So we'll verify. We're going to run it all the way through. Okay. That looks really good to me. I'm happy with that. So that is going to take us to the end of this video. And in the next video, we're going to go through how we can turn this operation into our second op. Because this is a 2-op part, we need to take the back off now. So I'm going to show you how we set up the file and we start preparation for the second op. Okay, thank you for sticking through this long video. I didn't expect it to be this long, but there we are. Okay, see you in the next one.